Hi, as I said, my name is Brian Wood. I work at Samsung Electronics. My job is to essentially work on device security certifications, government certifications, and in part of my role, I've become one of the members from Samsung at the FIDO Alliance. And so what I want to talk to you tonight is what is FIDO and how is it important for security? As you can see, I titled this Authentication Everywhere. I'll get into what that is. I got a lot of slides, but don't worry, there's not much content on us, so they'll go quickly. So what is the problem? Well, as you can see, we've had a lot of data breaches. I updated this today. There was a list of 781 data breaches last year. They're running at $3.8 million to fix a breach. After you're done, we have over 1 billion records have been breached since 2012. Obviously, this is a big problem. And further is that, at least in 2012, 3/4 of these were all based upon some sort of weak password credentials. So we obviously have a problem that we need to solve. And we all are familiar with entering passwords in every day. And what do we do? So, as I said, we have a password problem. We need better authentication. The problem is, one-time passcodes, which is what most people are using, they're good for what they do, but there's a lot of problems in terms of the methodology and the use cases. I don't know how many of you people have used them. I've seen SMS tests, where you get the SMS passcodes, but obviously phones can be spoofed fairly easily. I've certainly used the one-time password tokens, RSA tokens, Vasco tokens. There's certainly nothing wrong with them, but they're also a pain in the butt to use. I know because I've had to use them every morning for years. So there's a lot of issues that we have with these, and what we want is something that's quicker, because we know that the real problem isn't so much the security people, it's everybody else who has to use it, because a couple of extra minutes worth of time and work in the morning just to log in means a lot of hassle for everybody. So what's the model that we're going to go? Well, this is what FIDO stands for. Fast Identity Online. The idea is to be able to provide a method that's easy to use, flexible enough to be able to handle any type of authentication system that you need. Now, what do? So, in the old paradigm that we have is security and usability are obviously divergent topics, right? If I want to make it secure, users probably don't want to use it. If I want to make it usable, it's probably not secure. FIDO is trying to make these go together so that we increase the usability, make it simple and easy to use, while also enhancing the security. So how do we get there? Well, if we look at old authentication, we do some sort of, usually a password or something similar. But for FIDO, what we actually do is we set up an intermediary system. And then we utilize some sort of a localized token. Okay, a good example would be my cell phone. And I authenticate to the cell phone. The cell phone proxies that connection because the cell phone knows who I am because I've told it so. Some back-end service knows that the cell phone has been registered, so it trusts that I've logged into the cell phone, and then I'm able to proxy that in to some other system. For example, a bank, my corporate network, my website, Amazon, PayPal, whatever it happens to be. Okay? So what we do is we set this up with PKI. Everybody remembers PKI. Nobody wants to do PKI, right? So the whole thing is that this is all done on the back end. It's all handled on the back end through the server and the client, and nobody ever touches the PKI. So that's the wonderful thing about it. We get all the benefits of the security of PKI and being able to know that this is who I say that I am without actually having to deal with distributing the keys, without having to deal with, do I trust this person, do I not trust it, what's the expiration, what's the certificate authority. It's all hidden on the back end, especially from the user. The user just knows I've authenticated. What happens in the back end is totally visible. Okay? So some examples. We have in FIDO 2 primary methods of authentication. We have essentially a second factor, they call it the U2F, which is basically your one-time password. So it looks fairly simple, similar to what you would expect. With some enhancements, I'm really not going to talk much about that because that really does still require, in general, some sort of external token, a USB token. So I'm mentioning it, but it's not really what the focus of my discussion here. The other one, though, is what we call the UAF, which is basically a biometric standard. Now, that is generally, most of these devices today, most, not all have some sort of fingerprint sensor on them. Okay, so what I can do is I can link the fingerprint sensor into a secure authentication solution that would tie back to anything on the back end. Okay, so I can get some sort of a challenge. It prompts me to type in, use my biometric, and then from there I can authenticate to something on the back end. Okay, if you've used PayPal's authentication, some of the phones have the PayPal authentication with the fingerprint sensor. Basically that. Apple, similar, except that it's not FIDO, because of course Apple kind of does everything on their own. But it's that same idea. So the way this is set up is obviously I have to register, but again, it's a simple process. The user would register to whatever the system is that they want. So if it's, say, my corporate network, and I want to register them in, I set up on the back-end services. I have a website set up. They go in, they set that up, they log in, they register, they get an invitation that then they're allowed to quickly link in with their device to authenticate to their device. And then that creates the linkage between my device, my identity, and whatever that service is. Now, the thing is, you might be thinking, but I want to use this for more than one service, right? I don't want to have to go in and, my bank has one, and my enterprise has another one, and Amazon's got a third one, and I want to be able to use this for all of those. This system is set up for that. But what it does is each individual server on the back end has its own individual linkage, and the two cannot be shared. So if I register for Amazon, I can use my fingerprint to register my device to Amazon to be able to authorize that. And then if I want to go to PayPal, I can do it again. And on the back end, PayPal does not know that I've registered for Amazon. Amazon does not know that I've registered for PayPal. Okay, they're all maintained separately. So each identity is, from you, it's you, but on the back end, each one is considered to be a separate identity with its own PKI keys. So when I want to use it, I go to wherever it is I'm going to use it. Could be an app, could be a website, whatever it happens to be. I get a challenge. I get basically like a prompt. Please enter your fingerprint. I scan my fingerprint. It finds the appropriate key, generates the protocol to be able to say, yes, you are who you say you are, and sends that back to the server. Server knows it's you, and then you're allowed to proceed with your identity. Never did you have to enter a password, maybe a username up front to say that it's you. But that's about it. The idea is that it's simple, easy to use. Most everybody can usually figure out how to stick a finger on their phone. And of course, this system, while I'm talking fingerprints, is not specifically limited to fingerprints. If I want to do voice, as long as I have somebody writes a client that will recognize my voice, I can use voice. If I want to do face or some other, whatever it is, iris, whatever all the fancy things everybody's talking about for the next gen biometrics, I can use any one of those as long as that company has linked in to be able to utilize a FIDO client that'll do that. So basically what you see here is, how do I enroll? This is what I've just been talking about. Some of the things that we have, obviously this is getting in a little bit technical, but the basic thing is we have a stack that includes two pieces. We have a user device, whatever that happens to be. I'll say, for example, my phone right here is a FIDO client device. So it has the authenticator, which is usually locked away in some secure space on the phone. If anybody of you have ever heard of trusted execution environments or TPMs, things like that, that's where we store all the keys. That's where we do the secret stuff. Okay. Then we have an ASM, which is basically a translation layer for anybody to be able to use. And then we actually have the client itself, which is just my kind of normal app that gives me all the APIs to interface into everybody. And then whatever my app is, for example, PayPal's app or Samsung Pay's app actually uses this same thing on the back end.
This user device, FIDO client, ASM, and FIDO Authenticator appears on the device when you install the...
So in general, what's happened with most of the phone providers is that this, from here down, is a blob, right? Because while theoretically you could have different components here, Maybe in the Windows world, that might be more common. Microsoft's Windows 10 has this built in, and there you might get different components. But on the Android world in the mobile phone space, because of the way the controls are locked down and access to the secure areas of the phone, generally this is a blob. And so it's, Samsung writes this, Samsung puts it on the phone, and then, people can gain access to it up here. And I think that the reality is, I think that that's how it's going to be in most cases. Most of the vendors will end up putting in that kind of I'll say it's the blob with all of those components built as one. Then over on the back end, on what they call the relying party, basically that's your Amazon or your PayPal, whoever it is that's actually providing the service that you're authenticating to. So they have some sort of a web server, obviously, that needs to communicate to the client. And then they have their FIDO server on the back end that would actually, verify the identity that's being passed. Okay. So we also are working on at FIDO some additional security, what's called a metadata service. Basically what that would allow is so somebody could know that this is a Samsung such and such phone that's been security validated or has certain capabilities on it, so that different devices could be noted for different security levels. And then a relying party could say, well, I don't trust that device because it's only software. I trust that one over there because it's a combination of software and hardware, and they can make the risk decisions. So these are things that FIDO is working on standing up to be able to provide so that you can extend this out. Quick example. So as I said before, PayPal is a good example. PayPal is on the FIDO board. They were one of the very first applications to come out that actually supported FIDO. So they've been working on it for quite a while. So in this case, you can see that they've got kind of a shopping app up here, and they're getting ready to check out, and there's a little PayPal button. So they click the PayPal button, and it pops up and says, okay, would you like to log on? And here I could change my logon option. I could type in my PayPal password, or I can just hit my fingerprint at the bottom. I go through, say, yep, oh, here you are, let's go. And then off you are into your purchase, and all you had to do is tap the fingerprint. Okay. So the thing with FIDO is that they're looking for this to be, in addition to secure, is private, right? Because the thing that a lot of people are worried about is, where does those biometrics go, right? Because obviously in this case we're focused on using a fingerprint or facial recognition or iris, whatever that is, voice print. Where is that going? In FIDO's implementation, that data never leaves the device. So while there are systems that are out there and have need for, like voice recognition over the phone that goes to some server, or things that do get transmitted, that is not FIDO's goal. FIDO's goal is that your identity is yours, and it's on your device, never leaves this device, and is only accessible to you. So whoever it is that relying party is, whether it's Amazon or PayPal or Samsung or whoever, they have no idea who you are. All they know is that you have said that you've linked this device, which knows who you are, to some service that they provide. And that's it. They don't actually get to see the identity information. All they get is, during the enrollment, they exchange those PKI keys. That's it. That's all they ever get. And every identity partner that you go to, so no matter what service it is, you establish a new set of keys for every single one of them. Okay? So because of that, we like to think that FIDO will enable privacy while we're enabling strong authentication. So the idea here, of course, better security for online services, reduced costs for the enterprise, and simpler and safer for consumers. So now, why was I saying authentication everywhere? Well, that comes down to basically these devices, right? So some scenarios that we're looking into, right, is enterprises want to enable strong security, and strong authentication in their organizations, right? So today, of course, we set long password rules, 10 characters and complex, and every 30 days they get reset, and and you can't use the last 20 passwords, and so nobody ever remembers what it is, and you're always kind of stuck trying to figure out what your password is and how to reset it, and hopefully you don't go on vacation when the password had to be reset and you get locked out. So with all of that, what we're looking at is how do we expand essentially higher factor authentication into the enterprise. Well, obviously that's where FIDO is looking. But here's the thing. If I wanted to go and say, take RSA tokens out to everybody, right? It's one-time passwords. It's a well-known system, long established. Okay, I got to buy, say, 1,000 of these tokens plus extras for everybody in my organization. That's a lot of cost, right? And then everybody's stuck with this token that they got to carry around and remember to do, and their PIN, and that, and everything else. On the other hand, if I got to go with something like FIDO, I put on a FIDO server on the back end, or since most places are running Microsoft Windows, you run a Windows 2016 server, which has it built in, right? I turn on FIDO authentication, and what do I use as the authenticator? Well, most people, not everybody, but most people have some sort of a smartphone. A lot of these phones are starting to include FIDO clients in them. So could I, instead of forking over all this money for RSA tokens, tell you to register your phone to my service, and now I can utilize your phone for my authentication because it's your phone. How often do you leave it around? Yes, some people, occasionally they get lost, they get broken, whatever, but same thing happens with my RSA tokens. But most people that I know of are more likely to keep better track and care of their phone than they are their RSA token for the company. So now what I can do is expand this out to be able to enable authentication across a broader range, and theoretically I have a much smaller outlay for doing things. Okay, so I'll wrap up with a couple of quick slides on FIDO. So there's over 250 companies that are currently in it. It's an industry association. Samsung is one of the board members, so is Google, Microsoft, PayPal, several large banks like Wells Fargo just came on the board, Bank of America is on the board. FIDO is specifically targeting the authentication space inside the whole, user identity. Okay, we're not getting into federation. You can certainly federate IDs that are used in FIDO, but we don't get into that piece. We're specifically on the identification and authentication for them. Okay, and then just kind of some updates, to show here how it's progressing. In May or December of 2014, we released the first spec. We're currently on I think versions like 1.3 of that spec, 1.3, 1.4. We're working on releasing 2.0, which should come out in a few months. And it's been growing quite a bit. Obviously, Google is a big player in this. They're more focused on the one-time password, not the biometric piece, but they are starting to come around to the biometrics. As you can see here, we've gotten a lot of play. You see GitHub recently joined and is implementing the software on their site. Bank of America is using it for some of their components. Samsung uses it for Samsung Pay. It's the authentication factor that we actually use. So if you've seen any of the stuff for Samsung Pay, or if you have one of the new Samsung phones, you're actually using FIDO authentication when you're actually making your purchases. And these are some of the places that have certified their products for FIDO. Fast identity online. It's kind of a weird. Yes.
So I have a couple of questions, but I want to recap the architecture. So it sounds simply to me as if during registration, you get an invitation to register. Each entity has its own FIDO key server.
Yes.
It drops down my private keys upon registration.
It actually does kind of a generation, and then agreement on with a public key exchange.
Works,
yes.
The result is I've got some private keys. So it's multi-factor. There's
right.
something I've got and something that I know.
Right.
So in this case, what you're saying is I get on, I log in, and if it's true two-factor, I put in a password. Then I use my biometric. It unlocks the private key. So I have clients now who are doing multi-factor by driving private keys into devices.
Right.
So once somebody logs into the device,
yes.
they're on. One of my clients got rid of all their RSA. No more tokens. They're on using AD. They're on certificate-based authentication.
Okay.
Certificates.
Yeah.
And that's the Juniper spinoff. I'm trying to remember what the name of that is.
Yes.
Pulse. Yeah.
Okay.
Pulse. That's a Pulse implementation. Okay, so the question is, how much traction are you getting after the PCI Council announced that there's going to be new increased requirements for using multi-factor authentication for administering payment systems?
Several of the board members are actually a very large financial institutions, so we've been getting traction prior to that. So the expectation is we'll see another uptick of the lower end, not just the big banks, but of the rest of the players in the space. But since that kind of just came out as an official thing, but like we have, Bank of America and I'm trying to think of the other name. Visa, MasterCard, Bank of America, Wells Fargo are all on the board.
Right. What about some of the other players in the multi-factor space, like Vasco?
Vasco's just joined.
RSA.
I think they just joined the board. RSA is not a member.
Okay.
Or they might be a member, but they're not on the board.
Yeah, I'm missing SafeNet. Well, no, SafeNet's, I don't know. They do two-factor.
They do. I think they might be an associate member. I don't remember all of the.
Okay. I wanted to ask about spoofing registration.
Sure.
Because I think, I'm not going to explain it, but a lot of people will probably know that Apple Pay got spoofed on registration. How does this, or is that just because the people who set up the vulnerability for a registration spoof were just, we're substituting convenience for security?
It's much more how are you setting it up.
Okay.
That really comes down to what's your risk.
So I have a question kind of related to this question. So usually the PKI kind of methodology says there's going to be a certificate authority, which means that there's going to be some kind of third-party server that kind of tell you that you are what you are.
No, not here.
So you don't have it here. The question is, are you guys planning to add it?
No.
So who's going to be like
So the relying party knows who their certificates are, and you have a one-to-one relationship between my identity and you. And then when I go to register for him, I have a one-to-one relationship with him with a completely different set of certificates. So we don't have the whole, I have to have some global person who's going to tell me that all of these are okay. You and I have our certificate. He and I have our certificate. She and I has our certificate. And so it's a one-to-one specific trusted that way.
But when you're talking with someone, I mean, obviously you need, a service to basically participate and be familiar with that type of communication.
Right.
So how many actual web servers or web solutions out there already can, have this capability today?
I think there are more today that have the U2F, the more two-factor versus the biometric, whereas the biometric is currently getting a lot more play for apps that are on the device, on the phones. So it's not to say that you can't use them in both places, but I think we're getting a lot more current integration with biometrics for things that are going on the phone, like PayPal's app versus logging into Google services. So I think right now, that's kind of where the distinction is occurring. But Microsoft, Windows 10, they implemented draft version 2 of the spec for UAF for the biometrics into Windows 10. So that's starting to drive the integration through Windows into other things.
Right, so developers can basically...
Exactly, because there's now there's a Windows API, it's in your developer kit, it's in Visual Studio, and boom, you can go. There's some expectation, but it's not clear that Google may implement some of this into core Android, at which point then all the Android vendors start to get it. And Apple, we never know what's going to happen there. Yeah.
If I lose my phone,
yes,
and I need to re-register, I assume.
Yes.
Okay. Do I get the private keys?
You would be generating a brand new identity. You might be linking with an account.
Who's generating? The vendor generates or my phone does?
Both. They each generate. So the phone will generate and then pass the public key up, and then it's going to get. There's going to be there's like a. I'm trying to remember. I think it's like a shared secret that will get passed between the two to be implemented. It's kind of like the signing thing. But basically, the keys are generated locally, and then the public key is used to pass up for signing. But then, but the private key never leaves the phone.
Now, you don't do password, you don't have security questions, right? How do I convince Amazon that I'm not somebody who is an imposter, but I'm re-registering my new phone? How do I do it?
That's up to Amazon. I mean, that's really up to Amazon as to how they do it. Yeah. I mean, how do they do password resets today?
Somehow,
right. But the expectation is that you would have kind of like today, you forgot your Amazon password. What do you do? Well, we have a password reset mechanism, and you would basically have a register new device mechanism. And then you would go in and re-register. You'd have to, of course, prove that you are who you are in some other manner. And then, then we will deregister the old device and register the new device. But it's not going to push down your old keys because it's a new device.
Okay, perfect. Thank you very much, Brian.